Our last review video here covers question 10 and the bonus. In question 10, you are given a revenue function. Revenue, remember, is the amount of money being taken in any commercial enterprise. And we're asked to determine the marginal revenue at a production level of 450 units. So to determine the marginal revenue, we have to calculate the derivative of the revenue function. And this is a very simple function to calculate the derivative of. You'll see that as a lot of these functions, it's in ascending order as opposed to descending order that mathematicians prefer. Nonetheless, this one is in ascending order. So to calculate the derivative, you just use the power rule. That means we bring the 2 around front here, and the 2 then cancels with the 2 in the denominator and leaves 25, and then 1 from 2 is 1. So this term differentiates to x over 25. There's a negative in front, and that comes along. And then this is a linear term, meaning that the x is raised to the first power, and 1 minus 1 is 0. Anything to the 0 is 1, so this is 20 times 1, and so that's why whenever we have a linear term, it just differentiates to the coefficient of that term. So that's our marginal revenue function, and we substitute in 450 for the x, which is the quantity. That's the quantity, the production level, 450 units. And so we substitute 450 wherever we have an x. Wherever we have an x, we put some parentheses, and inside those parentheses we substitute that value, 450. 450 divided by 25 is 18, and 20 minus 18 is 2. So that's the marginal revenue at a production level of 450 units. Since it's positive, that means that the rate at which revenue is changing is increasing, and that rate is $2 per unit produced. So it's positive 2. That means it's increasing at the rate of $2 per unit produced. When we do the same for 550 units, then we see 550 divided by 25, same derivative with a different value substituted in. And so 550 divided by 25 is 22, so we subtract 22 from 20, that gives us a negative 2. And so at a production level of 550 units, revenue is decreasing because this is a negative number. So it is decreasing at the rate of $2 per unit produced. So that's number 10, marginal revenue. Okay, here's a look at the bonus. And you had, on the practice, you had a blank graph, and on the actual exam you'll have a blank graph. And so you're supposed to sketch some sort of function, any kind of function, as long as it's actually a function, which, as odd as it looks, this is. But you're sketching a function that satisfies 6 different conditions. Now, I would suggest that you sketch a graph like this, a blank graph, on a piece of scratch paper, and work through that, knocking these out one at a time until you can get all 6, or as many as you can get, and then copy that on your test paper. Unless you're really running out of time, then you don't want to have a nice graph and then you're out of time to copy it. Anyway, I would suggest that you start with a condition like this that cannot be interpreted any other way. This says the value of the function at x equals 2 is 0. So it doesn't matter whether you have a point there, like I do, just a point, or you have the function passing through that point. There's no other way to interpret that. So there's others that we need to define here. For instance, f of 0 is undefined. So you could put an open circle, as I have here, where my function graph is passing through, or I could have had this function in two pieces, where this one is is down here, and this one's where it is, but you would not have the line or crossing the y-axis or a solid point anywhere on the y-axis. Now let's go through these. So that's those two, and let me go through these. And there's a typo in here I'll point out momentarily, but this says the limit as x approaches 1 does not exist. Well, here's 1, and as x approaches 1 from the left, we see that is approaching, the function value is approaching 0. And as it is approaching from the right, the function value is approaching 1. So they don't meet up, and so the left side limit and the right side limit are not the same. So that's the limit not existing. Now the next one says the limit as x approaches 0 is equal to 1. Well, as x approaches 0 from the left and x approaches 0 from the right, the function graph is heading to the same place. X is 0, y is 1. Doesn't matter that the function's not defined here. It's still where the function is heading. The function value is heading to 1, whether we're coming from the right or we're coming from the left. It's still heading to 1. Now this is the condition that has a typo. And it is the condition that has the typo. I drew the graph first and then typed up the conditions. But this says the limit as x approaches 1 from the right is less than the limit as x approaches 2 left or right. Well, it should have been limit as x approaches 1 from the left. So this should be a little minus sign right there, because the limit as x approaches 1 from the left is 0. And the limit as x approaches 2 is the function value of 1. So that was, that was a mistake. Now the limit as x approaches 1 from the left is, as I said before, 0. So that condition is met. That condition is met by this graph. Okay, that's everything. And good luck to you. If you have any questions, give me an email, shoot me an email, or a text.